yesterday, like last week, uh, we were talking about version control system.
Mhm.
And on that presentation, I told you we have two major architecture. One is centralized version control system, like SVN, as we explained and talked, and the other thing is distributed version control system. Of course, the beginning of those are the same, like what is version control system, how it can help us, and so on. So that's why these 2 weeks have a small overlap in the theory, because yeah, about version control, why we need it, and these things. So it's almost, we will skip it, but I have put some small review. So again, we understand what is it and why we need it, and like the architecture of both types of centralized and distributed. And then we will go this week with the distributed version control system rather than centralized. Okay. So the content is for this week is what is a distributed version control system? What is Git? Okay, let me talk about first two at in the beginning. You know, as I said, this time is distributed version control system, like opposite of centralized. And last week we were talking about SVN. This time we choose Git as our option. It is like SVN, but for the distributed version control system. And then we will go a bit practically with the comments, how to use this Git. Like last week, we were talking about how to use SVN, this time about the Git. And then we will go how to use Git with remote mode. I mean, like that website Helix Hub, but we have an alternative for that, which is more famous. It is called GitHub. I will explain all of them. So I just wanted to know this first, this main four stage of the this week. So let's do a quick reminder of version control system. So as we said, uh, a version control system is basically a tool that help a software team or even a person to manage the code during the time, to manage all the changes during the time, change of source code. Because as I said, there are many people, and a software has many versions, and as you go, continue, your software grows. With this, you not only have a backup, but you have a saved state of each step during the time. So, and also, as I said, the version control system keep tracks of every modification, even single change in a code, in special type of database. Yeah. So why we need it? As I said, if a mistake happens, we can go back and before that problem and fix the problem. And also, if we are going to work with other colleagues, it helps us to, let's say, some kind of cooperate, avoid the conflict, and if a conflict happens, helps us to resolve it, and so on. Okay, a version control system can be centralized, like last week, or distributed, which is this week. Let's look again of some kind of scheme of the architectures. So centralized version control system, if you remember, you know now what is a working copy. I will briefly say it again. A working copy is the directory that all your project is in, like files, folder, and everything. And we have another term called repository. It is the same thing, but in the eye of a version control system, like including the files, folders, also the history of the changes. So in a centralized version control system, we directly put the changes to the repository. We call it commit, and we update our working copy, which yeah, the name is update or check out, as you remember. So directly there is a server which is somewhere on internet, or I don't know, somewhere or network, and we directly connect and update our stuff there. So but about a distributed version control system, which we are going to talk this week, as you said, still we have a working directory and still we have a repository. But rather than have a direct connection to from working copy to repository, we have an intermediate stage. It is like we make a copy of a repository for ourselves, then we are working in, let's say, our own garage, let's say just commit update, commit update, commit update. So it is not on internet, this repository here. Then when everything was ready, we push all the changes all together to the server, which is shared between everyone. So rather than, so when we have many people working on same project, this is really better because you don't, for every changes, imagine like a server should, if it's not if it's like a centralized and you have a direct connection, and imagine there is thousands of programmers, like every time this server should manage because all the changes are committed directly to the server. But here, no, every user have its own and they are working for their own, and when everything was okay, then it is sent to the server. So yeah, and it is faster, of course. Why? Because when it is on your own computer, you don't have that network delay. And yeah, you have some redundancy because you copy a repository for many, many times, but speed is more valuable for us rather than, for example, 2 megabytes, 10 megabytes of our hard drive. So this is distributed. The main thing about it, it is for you to know we have a copy, local copy for ourselves. We work with the local copy, then we send it to the server. So now let's talk what is Git. So before that, a distributed version control system is an architecture, and a Git is a software of that specific architecture, is a specific, a special type of distributed version control system. It is very famous. Like, let's say if you go to a company and they tell you, okay, do you know version control system, and you say yes, you should like doubt that their default question was Git. It means, for example, let's say, I always tell the students with this example that imagine we have many language in the world, like, I don't know, Russian, English, Spanish, and everything. And when you say, for example, can you speak like a foreigner language? So Git is like English in that word. Means like it is more universally accepted between everyone. Okay, between everyone. And Git, let me just say a quick review of it. It is made by the guy who made the Linux kernel, and it is, yeah, it is a version control system, and uh, it is free, it is open source, and also you can integrate it with your IDEs. It means like they have some plugins, and with a single click you can use the Git. But of course, in this tutorial I will go to the command mode, to the core of it, because if you know this, things are way more easier for you. And yeah, it's enough for you to know that Git is the most famous version control system, no matter it is centralized or distributed. Goals of Git: yeah, it has speed, it is so fast, it supports non-linear development, like thousands of parallel branches. Like I will explain to you, I already mentioned what is branch, but I will explain it. We will work how a branch works, and you will see it. It means like basically when you have a software, you have different version of it, and different people are working on different versions. So it supports that and make it easy for you. Distributed, it is good. As I said, the good key point is it is able to handle large projects efficiently. So as I explained to you, distributed is better for the large project, and Git is the best type of distributed. So some hints on Git, let's say. Okay, if you remember, we in the centralized version control system, we were actually checking out a repository. We would say like, okay, check out and then link off the repository. If you remember, it was like that. Here, checkout is not that. We have some checkout, but I will explain. But this is not as centralized one. We have clone here, and we have pull here. Clone means to copy. Let me show you an example. Let me show you in the architecture. You know, I told you there is a repository, you make a copy for yourself. This making copy for the first time, it's called cloning. And when you repeatedly do just the updates, it's called pull. So we have two terms here. They are now like this, like maybe you might say, you will see it in real practical work. Okay. So we have cloning, means copying a repository on your computer, and pulling means updating your repository in your computer from the server to get the last changes. So, and your local copy is completely copy of everything on the remote server, and it is just as good as theirs. Yeah, it is just the same, and everyone copy the same thing. Uh, and many operations are local. As I said, you do the changes locally, and then when it was done, you will send it to the server. Like check in, check out is local, commits are local, and also gits keep the version history locally. And when you are ready, you push the changes to the server. So you will see. And let me show you just some difference between centralized version control system like SVN and Git. In SVN, for every file, we were tracking every file and during the time. But in Git, we say it's like, remember in the games, for example, you go to a level and then you press and you save the state of the game, and it's everything on that side, on that environment. Your level, your position of your enemies, and everything is saved just like that. Git is like a save state in a game. It saves everything all together, unlike Subversion that tracks each files and growth of each files. But Git tracks the state just like a save in a game. Yes, it might be more redundant because every time you save everything, but it is faster. And as I said, we don't care too much about how big it is. We want everything to be faster. So we basically save everything. As I gave you the example, just see it as when you save a state in a game. And okay, Git or distributed might be a bit more, let's say, has more parts rather than centralized one, because we have a local copy and we don't work directly with the remote. So there are some terms that you have to know. First, let's start with the simple ones. So you have a local and you have a remote. Everything on network or internet is remote, and everything on your computer we call it local. So remote is pretty the same. It is some place that we saved everything there. But what about local? Okay, in local you should know three terms. We have three places. So I will explain each of them, and then we will see how to change between the positions. So in local, you have something called working directory. Basically, working directory, as I said, is just like SVN, is the folder that your project is in. So the first step is working directory. And let me go to the last part. It's called local repository. So local repository, it's like when you commit the changes, it's you are actually saving everything there. But what is the thing in between? It is called staging area. It is just like some temporary stage that you add everything to it, and then you push everything that you had in a staging area in a all together to your local copy. I told you here we save everything all together. When you do a commit, not only one file but everything all together saved in a local repository. It is this. So you have a working directory that, like, normally you are working in a folder. You add everything that you want to the staging area, and when you do the commit, everything that was in a staging area will go to the local repository. So the process is like that. you add everything to a staging area, no matter it is 1 file, 2 file, 3 file, whatever. And then you do a commit and everything go to your local copy. And even up until here, everything is inside your computer. When everything was ready, then you do a push, you send everything to the remote. Of course, I understand this might look confusing now, but when I show you in real examples, you will see. And in this week, in between, I don't wait for presentation to be finished, but in between, I will go and we will start to work. So don't worry. You put everything to the staging area with a command called git add, and you do commit with a git commit. Yeah, pretty simple, understandable. Git add adds everything to a staging area, and git commit save this staging area for you in your local repository. Up until here, you are in your own computer. Git push, send it to server. Git pull gets it from the server. Okay, then we have merging and branching, as you remember on the last week, but I will explain it. I don't want to confuse you now. Just for now, I want you to know we have a staging area more than that centralized version. Okay, let me show it to you with another chart so you can understand it better. This is yellow part. It is in your own computer. This is what is on internet. Up until here in the middle, it's on your computer. So you are here basically on the yellow area. Okay, and your local repository, which I told you, the image I showed you, the intermediate repository. This is the repository on internet. This is the copy that you made. Okay, so you basically want to work with your own computer in the beginning, and then you will send it to the server. Okay, I told you we have a intermediate stage called a staging area. In your computer, this is a staging area. Some people call it index, but I will stick with the staging area for the sake of being like like completely the same in the whole. So it is a staging area. You are working on working space. You add everything here. You add another change here. You add different change here, and then you commit it all together to your repository. So you check out it again to your working copy. Then so this is the process on your computer. This is the intermediate stage that is added. Then when everything was good, you are at a good position, then you send it to server. So you have this staging area here. How do you connect to it? With the add command. And then you commit it. Okay, let's go. So let me show it in another chart and with another life cycle. I say it in different ways because I want you to understand the concept. Basically, you work like that. You modify the things. Well, when you do programming, basically you are modifying your source code, right? You are modifying your working directory, means you are adding lines, adding files, adding everything. Then you stage it, that intermediate thing, then you commit it. So remember, modify, stage, commit. So how it's going to be like that here? Okay, you have some untracked files. Untracked files means basically Git or version control system have no idea of them. Then you add them. Now when you add your files into your version control system, now your version control system is looking at them, is looking if they are changed, if they are deleted, if they are whatever. Okay, then you modify them, like adding a code, adding everything, and then you stage them. After a stage, you do the commit. So basically, this is for the first time. Then you do the modification, and then you do the stage. I know it might be confusing, but you will see them better in the practical part. And one other thing that I want you to know, and the difference between Git and SVN. If you remember, in SVN, we have different versions. For example, when we were do some change, it was telling us now you are at the revision 1, now you are at the revision 2, now you are at the revision 3. Do you remember?
Yeah.
Okay, but here we don't have such a thing. Rather than that, we have a hash code which generated with the SHA1 algorithm, and we don't care basically. It is a 40 character string. Like rather than saying version 1, version 2, it tells you that you are at version 1.3 HPQRS, like you have a bigger number. Why it is like that? Because it's going to support a huge amount of development. That's why rather than calling version 1, version 2 going by number, they are going by hash code. But usually the first 7 characters is enough. You will see it in the example. So rather than naming all 40, we will just stick with the first 7 because it is unique enough to differentiate between the other commits. You will see. Okay, let's, now, as I said, in this week, rather than going, let it the presentation to be finished and then continue, I will start to do some practical works in middle. So let's get started. I will create a let's create a folder just for our test. I will call it our class the decentralized version control system. Just something to go. So this is my folder, and I will open a terminal here. You basically open a PowerShell or command line here. But before that, you have to install Git on your computer. How? You basically go here and you select download Git. Okay,
Mhm.
so it is in this website git-scm.com. You go to this website. Of course, for me it says download for Linux, but it is pretty simple. You go for the Windows, and you get, according to your Windows, you can get
It's
the,
in gitccscm.com.
yeah. It is
Mhm.
here, and I will put them on Moodle as well. But yeah, you basically download it here, and it is enough for you to write Git on download Git. The first thing is git-scm. You go there, and you go to the Windows one, and then according to your Windows, you get 40, 64, or 32. You just download it and press next, next, next. Of course, it has some GUI clients as well, but I don't want you to go for that. They are even easy. Later, when you want to work with your own code, you simply install a plugin on your Visual Studio, let's say, and it will, with a simple click, it will do everything for you. So don't be scared of that, and don't think, oh, it is complicated. But now, if you know the core, definitely working with those it will be super easy for you. And when you understand it in the core, no matter you are using Linux, Mac, Windows, you will understand all. So at first you have to install Git on your computer. Okay?
Mhm.
So
Okay.
when you install it, then you have access to a command called Git. Like SVN, that everything started with SVN, here everything starts with Git. Okay? So so you install a Git, and on Git you have to in the beginning you have to, and it is for the first, like once you will do that, and forever. Let me put it on the another screen. You see here, you have to set a username and email for yourself.
Mhm.
Why? If you set it, then Git understand, because as I told you, each user have to have a unique name and ID, that we understand. Okay, for example, you change this, David changed that part, I changed this part, right? So you have to set your email and name once in your Git after installation. But when you do it once, you don't have to do it like later or every time. Just you will do it once. For example, as I told you, everything starts with Git. Git config is for that purpose. For example, if I say Git config dash dash global, I have written them here. And then, okay, you have a name dot name, and I will call it Sina. Let's just stick with Sina, right? So this is the comment that shows my name is Sina. Okay, it's set. And also email, git config. But as I said, just once you will do that, and forever you will have it. So rather than username, this time is user email. Okay, I will put, I don't know, my Hotmail. Rather than this, I will put like this, my email, sina.mirshahi at hotmail.com. Okay, so let me to see if I wrote right. Yeah, okay, that's it. If you want to make sure that you set everything right, you will use git config list. So it shows git config dash dash list. It basically lists your current status here. You see, my name is set to sina.mishe@hotmail.com as my email. And my name is Sina, and my editor is Nano. You don't want that because it is basically for Linux. Yeah, you just stick with that part. So let me go back to the, let's go for the presentation. Okay, so do you is it do you see it, or should I make it bigger? I
I
will.
see, I see, I see.
Okay, okay. So, for creating a repository, let me move this there so you will have a nicer view. Okay, wait. Uh, this no. Oh, okay. Wait. Sorry. Wait. I will close this and I will put it here and here and here. Okay. And cd our class. Okay, now I'm in this folder. Okay, you see, to create a repository, you have to use git init. Git init basically means that now I want this working directory to be a Git repository. Basically, you start everything with this. Okay, yeah. For example, so when I'm in this folder, right, and you have to be in your folder as well when you want to do that. And the first command is get init. Init means initialize basically, and it will create a folder here for me automatically, and this folder will keep everything. So let me try. You see, get init, and this folder here automatically created, right? Uh, so here is we have git init, and we start our work with git init, and then let's, for example, do some files. I just randomly add some files, create a file, empty file. Let us name it test.txt. Okay, so now I have a file, and if I write, if I want it to be added to my staging area. So whenever you create a new file and it is not tracked means now Git is not looking at it. Okay, so I should add everything. So git init and git add. I can name the file, means add this file, or if I just simply press dot, means add everything on the folder, right? So it means like stage everything on the folder, put everything here to the staging area. So it has been added. Okay, and then I'm going to commit it. So I will put like git commit with the commit command and dash m, just like svn, and then you put a like a command. For example, first file was added, right? And then it says the file was added. You see here, rather than a version, it gives me a hash code, but it is the short form of the hash code. Okay, so for the first time you do a git init, it means that this is a Git repository, and then you add everything. And so this is the most basic steps that you want to do. Yeah, there are other things that I will explain them later for you. So basically, I want you to understand the most important things. Well, Git init, as I told you, starts a Git repository. Git add file, add a file to your staging area. You can simply put a name of file after add, or as I said, if you put a dot, like here, if you put a dot, it adds everything. So it is like simpler. Git commit, oh, sorry, git git commit the changes for you, everything that is in your staging area. And git status basically shows your current status. It is very useful command. Basically, the good thing about it is whenever you, so remember this one, whenever you run this, it basically shows you, it gives you some hint that what should be your next step, what you should do the next. I will show you in examples and you will see. Git diff shows the difference between your working copy, like what you change, and what you put in your local repository. Git help, a command, you just help and it help you. Git pull and push. Push send it to the server, pull gets it from the server. There are many things that some of them I will explain, merge, like checkout, branch, and everything. And as you see in it here as well. So uh, let's work a bit with our repository. So I added a file and I put it in my repository, right? So basically these three steps is what I did. Git init, it is the only once you do it when you want to, I mean for each repository. That means, okay, make this folder a Git repository for me. That's it. Then you add your files to a staging area, then you commit. But now let's do some changes. If you remember, like 2 minutes ago, I told you Git status is really useful command for you. It shows you basically what you should do next. So it now says you are on a branch master. I will explain what is branch later. And nothing to commit. Working tree is clean. So because I already commit everything. So basically it told me nothing to commit. When you see this, it means, okay, everything is good. But now let's do some changes. I will open it in a text editor and we will do some changes. Okay, this is a text editor. So I will add, for example, hello, for example, some codes here, no matter which programming language you're using. So I will just save it. Okay, so now let's run git status, and if still it says everything is good or no. You see, here it tells me that this file test.txt has modified. Okay, so it means that, okay, we modified some files. It understands, okay, it has some files, and also it even tells you like what you should do. It says change not staged for commit. Git add the file name, or if you want to, like you want to cancel the changes, you can use git restore. So basically, that's why you don't have to use Git status. But in the beginning, that you are new to it, when you every time use Git status, it says that you can do this, you can do that, this is happening, and so by purpose, now I'm going to make some mistake, but we will see what will happen. In centralized version control system, we at this moment we were commit everything like svn commit, right? But here let's commit it, the changes, and see if it works or no. So some line added. So now I did some changes, I saved it, and I want to commit it. See, it didn't. Still, it repeats some error for me that it is modified. If it's successful, it gives you some kind of hash like here. Okay, but here it says, it is still red. So basically, it says whenever I told you, whenever you do some changes, you should put it to the staging area. Don't become confused that in SVN, when we use command add, it means that, okay, SVN, start to track that file. But here, add means start and put this file to the staging area. So add here is different rather than add there. So it means before commit, as even here suggested me, you have to add this file in your staging area. So let's add it. I can say git add name of the file, right? Like test .text. Or basically, if I, as I said, the simpler way, just if you add a dot, it will add everything, no matter even it's thousands of files. But here, since we only have one, I just put it. So I will put this, and now let's run git status. Remember, last time it says it's modified, but you have to commit it. Let's again use git status. So this time it tells me something else. Tells me that I have staged it but not committed it. Let's go back to the presentation. I show you again so you can now have better understanding. So basically, as I said, you have to stage everything and then commit everything. If I wanted to commit directly, like here, I was giving an error that no, it is not in the staging area, because you can only commit things that are here. So first, with the add comment, I put this file here, and now git status says, okay, there are some changes that you can commit them. So now I will put like git commit -m some line was added, right? So if I put that, now it gives me, see, one file change, two insertion, because I add two lines, and it gives me a hash code. Okay, so basically you add everything and then you commit. So then I will explain you, I will teach you some kind of shortcut, but as I said, every time you have to add and then you have to commit. Okay, now let's run git status and says if it tells us everything is working fine. Git status, you are on a branch master, nothing to commit, working is clean. Okay, now let's do another changes. So I will put like third line and I will save it, right? So I told you now I have to git add and then git commit, right? So you might say, oh, why should I every time do that in two stage? I will tell you, you can have some kind of shortcut. You can directly write git commit, but add a, dash a means add. So if you put this dash a, you don't have to every time add this part, right? Only if you add a new file, you have to do this. But for the changes, if you want to say stage it and commit it in a one line, you will just put dash a and then dash m, which is your message. I will write third line added. If you remember last time, without dash a, when I run commit, it gives me an error. But here, let's do it. See, third line, perfectly fine. So every time, then now you are easier, right? So don't be afraid. Then, for example, I will add like fourth line again. Then I will go a bit faster. Git commit dash a means stage it dash m and some kind of changes. Of course, it can be anything, but yeah. Okay. Now there is a command called git log. Of course, by name, you can understand what it is going to do. Git log gives me all the changes that I have done until now. You see? Here, it shows me that this is the last changes, but even you have some kind of uh, yeah, some kind of time that it is added this time, that time, this time, and some kind of with this message, some kind of change, and this. Okay. So basically, as you see, now when I put git log, it shows me it completely, right? So we have a commit, and who did it? Sina. What is Sina's email? This. At this time, what was the message behind it? Some kind of change. So this is another. This is another. So we can see that how our progress was changed. And also we can switch between them. Okay, we will see. I just wanted you to know that we have something called git log. Yeah. And let's run git status once again. Yeah, everything is clean. So let's go. Okay, here. I told you this. Okay. Yeah, as I said, you have to add every time each file, even it can be 2 files. But I told you, if you just simply put a dot here, you don't have to write all of this. And for commit is like, for example, git commit -m, like what I did, like fix bug blah blah or something. Sometimes, for example, there are some other commands called git restore. They are a bit less important, but let's see an example. Git restore a file, discard changes in your working directory. For example, I put some changes. Let's say fifth, a line to be discarded. Okay, and I saved it. Right now, I will write here git restore and then the name of the file, which is test.txt, right? So it means this line should be gone. So if I write this here and just see my text file says it should be reload. You see that file is gone. So yeah, basically these are less important. You will see there are many commands, but I just wanted to show you have ability to do many things. Even if you staged a file inside, I mean, if you add a file, like if you saved it and then you did git add, so it is now in your staging area, it is enough for you to add this part like staged area. It is on a stage everything from you. It's like you didn't use that add code. Okay, let's do it. Why not? Let's do it. I want you to see it better. So some I will write it some kind of test here, and let me stage it. You see now if I write git status, you see it says it is modified but not staged, and says use git add. Okay, let me use git add everything. Okay, now as I said, if I write git status, it says it is add staged but not committed. So let me use this command and we will see what will happen. You see now it is green. Git git restore and dash staged, name of the file here, right? So basically it should go from this back to this. Let's see if it happens or no. Now let's run git status. Git status. You see, it's like we did nothing. So basically it unstage everything. As I said, I don't want to confuse you. For example, you might never use this, right? So don't think that you have to use all of them. No. Basically, in real life, when you're a programmer, you are using basically init, commit, add, push, and pull and merge. So I'm telling this to you, but don't be afraid. During the time, you will understand all of them. And let me restore it to what I had. Okay, git status. So everything now is fine. Okay. So uh, as I said, git status, I already told you, shows everything. Git diff shows the difference for you. For example, let's see. Let's now, as you see, I will write git diff. Oh, I said git diff and name of the file, right? So it should shows nothing for me. You see, nothing, because the thing that I have changed, actually because I have changed nothing here. But let's do some kind of change. Okay, let's do some kind of change here, and for example, my change here, and now I will save it. Okay, if I run git diff, it shows the difference between my working directory and a staging area. So now let's run this command again. You see, it tells me that a line here after these, you see, a line here, my change here was happened here. So it shows me that my file have some changes with the status of the file in the staging area. So I can then understand that that I have something to change. But rather than this, I personally always use git status. It is easier because now I say write git status. You say, you have some kind of changes. So I will say, okay, git commit dash a dash m fixed bug. I don't know 54. Yeah, something. Right? Everything is now. Now if I run git diff test file, shows nothing because I committed it. So it shows that you have some changes. So rather than git diff, you can simply use git status. So yeah, git log, I already showed you that you can see the log of the files. And deleting a file, as I told you, if you cannot in git, you cannot go and simply put everything to trash or delete everything. If you want to delete a file, you should use git rm, means remove the file name. Yeah, I don't go with this because these are simple things, and as you said, it's just simply if I write git rm then test, it will delete it for me, but I don't want to delete it now. Okay, so if you want to delete a file, go with git rm. Don't directly delete anything here like this. And yeah, so uh, also sometimes you might make some kind of mistakes, right? For example, I told you, for example, let me show you the example. My mistake in code. Okay, and I'm going to add it, and then I'm going to commit it, git commit dash m dash m something, just something. Okay, you see here. Okay, now then later I understand, oh, I made some kind of mistake here, and I want to go back to the previous situation. So I will see my git log, okay, and then it shows me all the stages. So I want to go back to this stage, right? So it's enough for me to have the first 7 characters and then go back to this stage. For example, I will copy this, I want to go to this stage before something. Then I will write git checkout these 7 lines of code. So when I do that, it goes to the state adding this file. Okay, so if I now do this, okay, so now if I reload this, that part is gone. So basically, what you usually, I will explain later. Yeah, yeah, you can just git check out and I will git switch to go back to the last changes. My mistake here. So yeah, git switch dash. Yeah, as I said, not all of them are. It's one thing that you use. But the next one, I will tell you the next one. Okay. Now, if we want to go back to the some stage and put everything to that area, that time, like we cannot go further again. It's like, for example, imagine you have some kind of system restore on your Windows, and you backed up everything for, I don't know, some kind of date, and you want to go back to that time, and everything after that time will be gone. So it means I'm going to now go to before this mistake, but everything will be reset until that time. So that's why it is called hard reset. So let me show you git log again. For example, I want to go to this time, and everything like this will be deleted. Everything after that will be deleted. So let's see if I write git reset basically and dash dash hard, and then the first 7 line of the code. So okay, now I'm going there, and everything will be discarded. I don't have access to anything. Like if I write git log, I'm on the last part, and here it shows me I am here. You see my head is here, and everything is deleted after that. So you have a hard reset as well. As I said, you might not use all of them. It's just I'm mentioning them, that if you later need them, you can use them. But try to understand git add, git let's say git add, git commit, and everything, or do it all together. Okay, so let's talk about branching and merging. Okay, I told you, I showed you this chart in the previous class that, for example, we have some kind of, let's say, we can have different branches for a project. And this is, let's say, this is my main project. I can have an alpha version, I can have a beta version, I can have a free version, paid version, many versions, thousands of versions. So how to do this branching and merging? So I make a branch, and when I was ready, I will merge it with my main software. So that's it. But how to do it in let's say in Git? Okay, so I want to make different branches of this project. So how to do it? Basically, there is a command called branch. If I write just git branch, simply git branch, it shows me the branch I'm having. The default branch name is master. So it means I have a branch called master. This is that I'm working. This is basically, sorry, no, moment. Yeah, my master branch is this blue one here now. Okay, so when I write git branch, it shows me my current branch and list all branch. But let's create a branch. How to create it? With git branch command. If I say git branch, so let's say we want to have a alpha version. Okay, just name, and now it created. If I write git branch, it says you have master and alpha. But you see this star, it means now you are on the master branch. How to switch between them? Let's say I want to switch it. I will write git checkout. So checkout here means switching between the branches. And name of the branch alpha. Okay, switched to the branch alpha. Let's once again write git branch. See, I have master and alpha, but I am on alpha, unlike here, which I was in master. So again, I will go to the git checkout master. I will go to the master again. Okay, so I will create another branch as well. Let's say git branch. So git branch, name of the branch, beta. Huh? Just a simple thing. So if I write git branch, now I have master, beta, and alpha. As I told you, just like here, like imagine this is beta, this is alpha, for example. It can be as many as you want. So I do, why I'm doing that? Because basically I want to do some changes, and I don't want to ruin and mess with my original file. And when everything was ready, I will merge it with my main file. So let's do some merges, and let's see how it will be work. So let's go in the beginning in the alpha uh, alpha branch. So I will write git uh, checkout alpha. There are some shortcuts to create and switch in the same time, but I don't want to confuse you. Okay, I will go to the alpha branch. Now you are switched at the alpha. So let's say git branch, you see, to make sure. Yeah, we are in alpha. So if I change things here, means that things on master will remain the same. So let's see. For example, I will write some codes for the alpha version, right? And yeah, just let's do it. And of course, we commit and stage it. Git commit -a to stage it, -m to send the message. Alpha feature added. Okay, that's it. Okay, so I am here, and it is done in alpha. But if I switch, when I switch, everything here will be changed. If I switch back to the master, and let's see what will happen. Let's once again see where are we. We are in alpha. Now let's go to the master. Check out master. So now I'm in the master, right? So in master, as I said, the change that I made here should be gone. So you see, it says the file is changed. Let me see. See, that part is gone. So you see, it automatically reloads file for me. That's a good thing about Git. Now I'm thinking that I am opening a same folder, but whenever I switch the branch, these things are reloaded actually. That's why here you see that alpha branch is different than here. So let me show you again. Git. Let's go to another, let's say, branch. Git checkout beta this time. Okay, beta should look like the master as well because we haven't changed anything here. But rather than adding anything, I want to change something. I want by mistake to start some kind of conflict, right? So rather than here, rather than adding something in the I will put here, for example, beta version here code. Let's say, just see, and then I will git commit dash a dash. Don't worry, you will see them. Beta version changed some line. Okay, that's it. So now let's see, where are we? We are on branch beta. Okay, now let's go to the master. Git checkout master. So I'm going to branch master. Now I'm in branch master, right? If I'm going to branch master, as you see, it is the normal one. So now let's do some merging. Merging, let's see here again. You see, merge is, you see, I think the green one as alpha and think the yellow one as beta, right? So let's see. And I am now in the green one, and I made some changes, which you see, I added something on alpha version, and now I want to merge it with my original file. When I want to merge it, I want to be inside the main branch. I mean, I should be inside master to be able to merge. Okay, that's why I check out master first. Now I'm here on master. Now let's merge the file here, merge the branch here. Okay, how to merge it? Simply with the command called merge. Yeah, I think it is in the next. Yeah, no, here. Yeah, git merge, as you see, branch name. Okay, so git merge. What was the name? Alpha, right? So you see, it's a fast forward merge. Yeah, don't worry about that. Yeah, it's merged, it changed, and so now it should be reloaded. You see, it's like now, even though I am in the branch master, the change in the branch alpha came here, right? So now you see, if I write git branch, I am in master, but everything in the alpha came and merged with the master. But now let's merge beta as well. But we will face some kind of conflict. I did it by mistake, because by purpose. As you see, I changed the file rather than adding a file to make a conflict. So let's do the same process again. Git merge, this time beta. Okay, you see, it says conflict. There are some conflict, and so here, if I say, it automatically shows me here, like, these are your code. This is from here to here. This is the beta one. This is where you are. You see these bigger, lesser, some kind of sign. So I will manually, I should fix my change, but I understand now there is a conflict. I will delete this part. I will delete this part, also delete this part. And so I will change in a way I want it to be. I will say, okay, I want it to be like this. Then I save it. And if I write give a status, I just want you to see. You see, we have some kind of conflict. So if I want to fix the conflict and I said, okay, this conflict is fixed, it says here, you see, you have unmerged paths. I will add, like, I want to fix this conflict because I changed it. So I will write just git commit. That's it. That's it. Okay. So it automatically fixed. So now let's, if I like git status. Okay. Now I only have to stage the changes and say I want to keep this one just the way we did. For example, commit, sorry, git commit. So when you have a conflict, let me repeat it again. When you have a conflict, it shows you that you have a conflict. You open your file, you edit your file, you save your file, then you run a git commit. It marks that you solve the conflict. Then again, you do what you always did: git commit dash a dash m. I will like beta added to master and conflict fixed, just something. Now everything is fine. Now if I write git status, everything is fine. I fixed the conflict and things like that. So you might face sometimes a conflict. You have to fix your conflict. Then you run a git commit. Then git commit dash a dash m to commit. Right? That's it. So uh, now let's say again git branch. So we can even delete branches as well. I think deleting branch is like git branch. I think dash d, yeah, dash d, and name of alpha. Let's see if we can delete it. See, deleted branch alpha because now I don't need them. Then git branch dash d beta because I don't need them now as well. Now if I write, so dash d name of the branch will delete the branch for you. If I write git branch, I only should have the master branch. Yeah, I only have the master. So that's it. It is conflict, like how to solve a conflict. And of course, as I said, there are many automatic tools for them on your plugins you can install on your Visual Studio. But yeah, here, when you know them in the core, you will understand. Basically, even when you press those buttons in the background, they are doing these for you. But now know them in the core. So this is the, sometimes you will face some conflict. You go and fix the conflict, and then you save them and stage them. So now, up till now, I was talking about local repositories. But let's say sometimes now how to connect a remote repository to our local repository, or how to work with the remote repository. I will show you them as well. So, you know, uh, the most famous repository, this distributed version control system in the world is called GitHub. Okay, so uh, it's simply we go and create an account there, and then we can use that. Okay, let's go back to our. I will show you again. So we basically I just want you to know that we can add a repository from internet or network or whatever. Then we using push, we are sending these changes to that internet ones, or with pull we get the last changes from there. Okay, you might ask, what is this fetch and merge? Basically, let me show you in a photo, in an example. I think should be here. Yeah, you know, up until here, we were working until here, like it was our local. Okay, so when you want to, as I said, when you want to send these changes to the internet or server repository, remote repository, you do push. And when you want to get them, basically you first fetch them and then you merge them, just like what we did. But because it is time consuming, there is a command that save it for you. You just simply use pull command. So basically it's enough for you to push and pull, push and pull. That's it. You to go to the part that you want to, for example, fetch the changes and then merge the changes, because this way it would be easier for you. So you will see all of them when I do it on like manually for you. Let's see, let's go back. Yeah. So it is, I want, at this point, I want you to know you push the changes. I will explain them later. And you pull the changes. Pull the changes means getting the changes from server. Push the changes means sending the changes to the server. So as I said, GitHub is a online site for Git repositories. It also supports another type of repositories as well, but it is most famous for the Git repositories. You can create remote repositories. You can change the codes. Many famous projects in the world actually are hosted in GitHub, like Linux, like Chromium browser that you might use, like, I don't know, Brave browser. Many things actually are in the GitHub, so it is the most famous one, and you can put your projects there. I want you to create an account on it and to work with it. So you might say that some questions might happen. For example, do I always have to use GitHub to use Git? No. As you see, we were doing everything local. Even you might say, okay, I am alone and I don't have any colleagues and I don't care to put them on the remote server. For you, like on this stage, it is enough. But if you want to, for example, put them on internet to be safer, if your computer ruined, you have your codes, you put them on GitHub or any type of repositories. Is GitHub the only Git remote websites? No. There are GitLab, there are Bitbucket, and other things. But GitHub is the most famous one. Yeah. And so up until now, that was the, as I said, but we were practically working with them during the project. But let's go to the GitHub and see how to create an account, how to create a repository, and so on. So here, this is the GitHub website. So you basically, just like any other website, you go and sign up and press your email and name and everything, and that's it. Okay. But I already have an account. Then I go to the sign in and I will put my credentials and then I go to sign in. You see, there are some of the projects I made, and this is some projects for the university, for work. This is a robot and everything. I showed you some of them. So uh, if you want to create a repository, basically you have a place for repositories here. You just press new. There's a button called new, and you want to create a repository, right? So it means that, for example, just put a name, because I want to put my stuff there, right? So I will simply put, for example, some kind of name. I will say like sample repo. Just name this, okay? Or private. When it is public, every other one on internet can see the code that you are having. When it's private, only you see it or other people you want them to see, like your colleagues. But I just put it public for now. Okay. So basically, yeah, you just create a like public type of repository and just create it. As you see, now we are having a repository, okay? But now two scenarios might happen. Sometimes you don't have any codes in your computer and you first create a repository online, then you add everything there. But sometimes you already have something here. So like here, you already have some codes and changes. Now I just want to add this online remote repository to my current project. It's enough for me. It gives me some kind of link. I copy just like SVN, and then I will use this command git remote add origin, and it is basically any name that you want to put. And then I will add this let's say this link here. So let me show you how it works. So if I write git remote dash v, it shows me the remote. Oh, sorry, I wrote remove. Git remote dash v. So it shows nothing, means there is no online repository here for me. So I should use this remote add with a name and a link. So I will have some kind of repository there. So I will like git remote add a name like origin. Usually it is common to put origin. Then I will put this part. So git add. So it means now this repository is what I'm going to push in. So now let's check git remote dash v. Okay. Now you see this is shows that this is a remote repository added to my project. So you see here, basically, let me go to the repositories again. I will go to the my accounts here. So these are here. You can see your list of repositories. For example, this is what I just made here, sample repo, and you see this is it. You can have access to it like this, and there is nothing basically here. And so because I want to let's see here. I want to rename my own branch to the branch because the GitHub, the first default branch that it makes, its name is main. Okay, the name is main, but mine, if you remember, is master. So if I want to rename mine, they should have similar name. So I will basically go and rename mine. I will like git branch dash m and main. I rename mine master to main. Okay, now if I write git branch, yeah, it is main. So now I want to push everything there. So I told you git push that u and origin means the name of this remote. I name it here, right? Push to this remote my branch, which name is main. Okay, let's see. So git dash u, then git push dash u origin main. I'm saying send this main to the origin. Okay. Sorry, my mouse is like froze. So let's do it. So it wants my credential. My credential is on GitHub. Sina.mirshahi at. Of course, for you it would be different according to the account that you will make there. And the password, I will put my password. So you see, it is sending, actually uploading everything to the main branch. Okay. Even I could not rename it. If it was still the same, but sometimes it is better for you to have the similar name to the Git, which is usually GitHub, which usually creates main. So let's see on GitHub how it changes. This is my repository, right? So you see test now is here. As you see, because I have sent it here. So now whenever even I think I will git push, it still wants without mentioning the other parts, but it's better for you to mention them so you know what you are doing. So if I write, for example, let's do some more changes. For example, send to the remote change. Okay, and here I will put like git add dash git commit dash a dash m like some change, yes, something. Yeah, now I'm going to push dash u. I want to send to the origin because you might have different remotes. What? This branch. I want this branch to be center. If I didn't rename it, I would have put it master. Okay, so now here, my credentials, sina.mirshahi@hotmail.com, and then I will put my password. So imagine it's a real project. Now I did some changes. Let it be finished. Okay. Now let's see if some change will come here or no. You see, it came here. Now, if my other colleagues did the same process, they will have this as well, right? They can see and work with it as well. So let's see how it would be the vice versa, like how to get the changes. If imagine your colleague is do some changes, some like I don't know, like from a friend, yeah. Then I will save it here because you can on GitHub do changes directly. So now this is different from my repository. So for that, I will use Git pull. Okay, Git pull origin main means from origin get it to the main. Okay, so it says now it's merged, and now this should be changed from a friend. So it's enough for you to know that you have a Git push dash u and Git pull, right? So sending and receiving, right? And how to add let's say some kind of remote for you with Git remote, add and name it like whatever name you want, but usually people use that, and then link of that remote which whatever it is. So let me, up until now, we were working with our own project, like we were creating a project. So let's see how it would be look like if we, let me close this and even close this. Yeah, continue without saving and this. I want to go completely on some different things. So I will name it, I don't know, something, CCC. Okay, here, right? And let me open a terminal here. Okay, now let's think that there is already there is a repository, and I want to get that repository for the first time. I am not creating something and sending to it. Actually, I am the one who is going to be added to a project. So something already exists on a remote repository, and I want to add to that project. So, for example, I can go even on my own project, but let's go to other people's project because I want to see Brave, browser, core, GitHub. I just want to show you some other open source. You know open source, right? People make a project and put it on internet for everyone. You see, this is a very big project with many stuffs and many source codes and everything. It is a browser like Google Chrome, but it's completely open source. I will go here, like on that repository, and there is a section called code. And when I go here, I will go here and just copy it. That's it. Here, copy it. And yeah, I copied it. Yeah, on GitHub, you simply can download it on a zip file, but I don't want to do that. So, as I said, it already exists, or it is from my company, my friends, or whatever, and I want to be add to that project. So this time, rather than Git init, because Git init is when you want to create a project, I will use Git clone, means copy this link for me as a Git project. You see, it might takes a while because it is like a huge project, takes to download. Let's see. But everything from there will come here. Just, it might take a time, as you see, 20%. Yeah, already 100 megabytes. It's a huge project. But I just wanted to show you that you can even you can be added to other projects, you can be work with open source project and so on, anything that is anywhere. Now on GitHub it was this project and I was added, so wait for it to be, and then let's see. You see now it's almost 1 GB. And yeah, it's quite huge. It's basically now a browser. It's called Brave browser. It's like a Google Chrome, and now uh, because it is open source for everyone, and assume that I came here and I want to add to that project, right? So I go there, cd. I should go inside that folder. You see, if I go there, it has this .github, you know. So if, for example, now I have added to a project, no matter project, other people project, and so on. And I go, for example, to a code, I don't know, some kind of code, for example, yeah, it is like C++ and everything. I open it with text editor. Yeah, for example, assume that there is a project and I'm adding, for example, some kind of, but of course I cannot mess with their code. But for, I don't know, int a plus 0 to a something. Yeah, whatever. Yeah, just something. Okay. Then I'm going to save it locally, and then I will go here and git add everything, right? And git commit dash m, or I could simply put dash a dash m, like changes. Yeah, it understand there is some changes. Now let's see what is my branch name. Git branch. I'm on master. So if I write git dash u, sorry, git push dash u to their branch, like I don't know what is their branch name, but yeah, for example, origin, yeah. Let me see, git remote dash v, what is the name? Oh, again, I wrote git remote dash v. You see, its name is origin. Okay, so I will put like git push dash u origin. Mine is master. If I write master, then of course, if I put my credential, for example, it wouldn't be accepted. Why? Because yeah, it's there are some moderators that see, okay, who the hell made that change, and it will be rejected. But I just wanted to show you that sometimes that there is already existing repository, even it is your repository, rather than git init, git add, and then git add remote. It is simpler. It is very simple. You go and just say git clone, and then go to your folder, and then do the changes, and it automatically added understands the links because you already added there. So basically your approach can be vice versa. You can, for example, you can go to your account, you go to your profile and go to the repository and create an empty repository for yourself. Yeah, something, just something, and public and everything. So rather than first creating a repository and then adding everything to this, you can just go simply go there uh, and then use, for example, git clone name of that. It automatically will get it from your repository, will make it a Git repository, and you will have the address automatically in your project. So you can go to Git and then clone your project and then do the changes and everything. So that was it. I know it was like a bit more diverse because Git is very more, let's say, advanced than other version control system. I don't expect you to understand everything with details that I mentioned, but at least you have a overview of it and it's good. And of course, now if you face a problem, you can, for example, or you know enough to be able to search, you know enough to make a small project for yourself and so on. So that's it. And as I said, yeah, some people are even their major is just knowing Git. So it's, I mean, like something advanced. And but for you, like many of the commands that I told you might not be used in your real project, like git restore, git these things. You just put like commit, do the changes. Even your project might not have different branches, so you don't care about branches. uh, Push, pull, and that's it, right? But it is good for you to know. And of course, sometimes, like on your Visual Studio, if you're working with Mr. Luis, and he can introduce you a plugin for your uh, version for your Visual Studio, you do everything that I told you, like with the just a moment. But here now you know what is happening. What is it? It is like no matter which operating system, with IDE, it works every time, everywhere. So that's it. But I want you for the like yeah, this week it wouldn't be again like last week, not some kind of let's say assignment that you have to create. I only want you to create a GitHub account, okay, and then create a small project for yourself, okay, and then push some changes on that project. Basically, something like what we did. I think it was my test repo. Yeah. Basically, I just want you. No, it wasn't. Yeah. Let me go to the my repositories. Sorry. Yeah. When you go here on your repositories, yeah. Uh, Yeah, you just go to your repository sample and just enough for you to, I don't know, create a text file on your computer and put some changes, push some changes there. And of course, I can see the history of it, and you see all the commits that you did are here as well. So basically, and if you want it to be simpler, even you can, I don't know, at first go and create a GitHub project and then a repository and then clone it to your computer and then add a file and do some changes, commit it, and then push it. Okay? So
Okay.
right, and also I will on Moodle, I will put 2 video tutorials from different people on Git, which, as I understand, Git might be a bit more complex. So you can watch them as well on Moodle. Like next hour, you can have access to them if you check Moodle. So you will see them, and you can have use them as tutorial as well, and all the links that we have used, and of course the presentation of this week. You can have all of them there. And when you did your repository and you did some changes, just and make it public, just send the link of your project to me, like email it to me, right? How to get it? Actually, it is basically the one that you want to clone here, right? So you create it, copy it, and send it to me when you were done for that project. Okay?
Okay.
Okay. So do you have any question?
No.
Okay, so thank you for your attendance. I am aware, and as I said, I don't want you to be scared like it is like complicated and everything. As I said, it was an overview of it, and by practice, you will understand which are the most useful one for you, and you only go with those. And of course, there are many dozens, thousands of the tutorials on internet about Git. Okay, so we will get slow, and of course, if you have any question, let me know. So
Okay.
that's it, and it was our week, and so see you soon and next week.
Thanks
Good.
for listening. See you.
See you.
Bye.
Goodbye. Have a good day. Bye.